And to close out this week, I just want to talk a little bit about what I'm doing in the AG 3D printing lab. We got a new printer. We talked about it. Was it 2 episodes ago? Thanks to our friend Andrew Sink. It's an SLA LCD 3D printer. So if you've seen our Instagram page at AG 3D Printing, or even our Today in Space podcast at Today in Space Pod on Instagram, we've been sharing our learning experience, if that's if that's the word we're going to use for it. Every time you pick up a new 3D printer, anyone that's new to this, it is a learning curve. It's a piece of machinery. It's essentially a robot, and there's a lot of nuances you've got to learn. It's a great thing for someone who's starting out or really wants to learn electronics and plastics and manufacturing. It's something that can really give you a ton of great experience, especially if you want to go down that route of being a tinkerer or a maker, or joining an industry like the 3D printing industry, which there are plenty of jobs, as I can tell you, someone working in it. There's a lot of potential, especially someone who does that, who buys a printer and learns it, right? So that's how I started. I bought a printer when I was a young engineer, and I had some extra money. My loans still hadn't kicked in. I was still in college working a full-time job. So I figured, you know what? Silly enough, I was like, instead of paying interest so that my loans go down, I was like, let me put some money into a 3D printer. And although at that time it may have seemed like a silly thing to do, that one investment of buying my first 3D printer, which was, I believe it was $1,500, that $1,500 has changed the trajectory of my career, of my life, of just me enjoying being an engineer, of enjoying being a problem solver, enjoying bringing ideas into reality. And the one that I started with was an FDM 3D printer. Fused deposition modeling is what that stands for, or the general term, because FDM is actually a trademark term, from what I understand. It's FFF, fused filament fabrication, and basically it's a piece of filament, what's the way to describe it to someone that's never seen it before? It's like a string of rigid plastic for the most part, and it's spun on a roll of plastic, and you put that into a hot end, which is a little aluminum block with a heater in it and a nozzle. And that squirts it just like you would have like a cake frosting, right? With one of those nozzles, and you're squirting frosting to make shapes and to cover things. You're doing that in a controlled space with a 3D printer. And while that may seem complicated, it's actually one of the easiest 3D printing processes that are out there. It's not a lot of cost to get into it. You don't have any extra processes really afterwards. You can sand it and you can paint it, but really, once you print it, it's done. So for anyone starting out, it's one of the safest and cheapest ways to get into 3D printing. One of the older 3D printing technologies is SLA 3D printing, which started off as lasers that would have a vat of resin, and a flat bed would come down from the top. We're probably going to have a video here of me working with it right now. Goes into the vat, and then the laser would etch and cure the material, harden that liquid resin into a shape, whatever shape that you're doing it, layer by layer, and then it would lift, go back into the vat, and do the next one, and it would do that constantly and go up, and then you would have this part hanging upside down on that bed plate that you could then use and you cure it with UV light, and that's your end thing. And so luckily, years into developing with 3D printing, some decades later, now it's simpler, where now you just have an LCD screen, just like you do on your phone, that shows a shape that lets the UV light that's from below shine through that shape, cure into that shape, and then lift it up. So you don't need the expense of a laser and running that and all the things that come with that. And you can still achieve 3D models in that same typical way. And so that is brand new to me. And it's been interesting because I have to relearn everything, right? And this is just like anything else. It doesn't have to be 3D printing, and it doesn't have to be science. It could be anything in life. Whenever you're learning something new, you either don't know what you don't know, which is, I think, most of the case, but there's also times where you know enough about something similar and then you have to unlearn those things. And that's where I'm at right now with this SLA 3D printing. I'm at this stage where I know almost too much, and stupid things like bed leveling on my FFF 3D printer, the stuff that you'll see on our Instagram page, AG3D Printing. The majority of that is FFF 3D printing. Bed leveling on that is very, very different to bed leveling on an SLA 3D printer. One of the really interesting things I was thinking of recently as I'm trying to relearn this is with FDM 3D printing, you're utilizing gravity in a way that, when you're building stuff from a bottom plate and then building up, your materials, as long as you have support underneath it for areas that, the filament is being built not on top of something else, gravity will allow that material to sit on that support, and then you can just build up. So you don't have to worry about gravity so much, it's actually helping you, right? But with SLA 3D printing, it's the exact opposite. And you're building against, with gravity. And that makes adhesion and making that first layer, which is everything in 3D printing, so much more important. And it even changes how you support something. With the SLA 3D printing, you have all these, it's like tiny scaffolding that's attaching the part, and you're basically floating the part that you're trying to make on the scaffolding, so that by the time the part actually starts getting made, you have all these tiny connections on the bottom of that bottom of that plate that's lifting up out of the resin, so that it can support the heaviness of the part that you're building upside down, which is just totally different than how you would do it the way that I know it. So luckily, I have a great friend, Andrew, that I can kind of reach out to whenever I'm working on it to say, hey, am I doing this right? Which I haven't been. So it's been interesting. But the challenge is really the mess of SLA 3D printing and the toxicity. Luckily, I've bought some stuff from Matter Hackers, which is a company that sells 3D printing materials. They kind of give you a place to buy all that stuff. It's all in one place, instead of just being, we make this piece of this 3D printer. It's a shop to go to. So anyways, they have some stuff that doesn't have epoxy in it. So it's a little less toxic, still toxic, but a little less toxic. And cleaning out whenever you make a mistake. So the cost of making a mistake on SLA 3D printing is in your time and with safety. So I don't have the proper ventilation to do all the stuff I'd like to do when I make a mistake to clean it up, because I've got to wipe down all those areas that have resin on it every time I make a mistake, and then I basically have to throw that away as soon as I can, because that stench from not only using the resin but also from using isopropyl alcohol to clean it, it's just it's not nice. So I will eventually, I think, offer this as a service for AG3D, but I've still got a lot to learn. So just, if anyone thinks that I'm some kind of robot and I don't fail, that is wrong. I fail all the time, and that's what makes me better. But and being open to the failure, and like SpaceX does, fail forward, that is the right direction to be in, because the world does not play nicely. Reality is not just theoretical. You also have to take what you think might happen and test it in the real world. And most of the time you learn stuff doesn't work the way that you wanted it to. When the rubber hits the road, things don't work that great sometimes. So you got to adjust, you got to change things up. And that's where I'm at this week. So